Hi dear professor, today's presentation is titled Integrative Analysis of Service Process from Diverse Environments. In this talk, we will explore three distinct settings: the arid basin of the Magi deserts, the dynamic delta of Bangladesh, and the active volcanic island of Stan Vincent. Although those regions differ greatly in climate and tectonic setting, they each offer valuable insight into how surface process shape sedimentary deposit. Let's begin with the Mojave Desert arid base. This environment is characterized by a dry, hot climate and episodic fresh flood dominate. And actually, in this place, it's a temporary lake just occurred in this place about 12,000 years ago. So I will introduce the rock type located at this desert. Yeah, actually it's sandstone. So for 542 sandstone simple, it's fill granites and well sorted quartz and feldspar. So it contains moderate maturity and high percent compositional. And for 845 sandstone, it's medium sand and subrondate, and it formed because fluvial deposits desert by wind below sand. Moreover, most samples in this area possess large-scale cross-bending because suffer oxidizing environments. When we're talking about how desert was formation and what is geological significance, our total is because wind drive dynamics and episodic water flow from fresh flow. The modern landscape is sculpted by persistent wind erosion and the intermittent yet powerful acting of water as detailed in Lecture 7 on desert process. Over geological time, those well-sorted, well-rounded grains become cemented, forming a coarse arenates as emphasized in Lecture 2 on clastic rocks. The resulting sandstone exhibits extensive cross-bending and other sedimentary structure in Lecture 4, which serve as records of ancient dew migration and water dry reworking. Well, next we shift our focus to the deltaic environment of Bangladesh. Here, the Ganges and Brahmaputra River deliver tremendous amounts of sediments, mainly fell granite silt and fell sand from the Himalaya. The massive sediment load builds delta, which is further modified by till action. Before we're talking about T action, we should talk about rock type at first. So for sample 532, its subtle lamination is seen. Planar layer stress sediment was deposited in relatively clean water, and for its overall uniformity, a consistent fill matrix with no observing sorting, and its millstone is typical form where water is relatively still, allowing fill sediment to set out of suspension. So Bangladesh Delta is the idealized place to accumulate millstone on T-flats. And for simple 541 is siltstone, moderate to moderately high in both composition and textural maturity, reflecting slightly more weathering, reworking, and swelling evident in high quartz content and more distinct laminations. And for its relatively high quartz content for millstone, reflecting a stable mineral in repeated tie fresh. So why massive sediment load builds the delta total is because T-action, motional flooding, and the stabilizing influence of mangrove forest. If you see the right-hand graph, it will prove that the sediments located at the river, how they do that. And so this will resulting in the deposition of millstone, siltstone, and organic rich calcstone. The fine lamination and interbedded organic layer provide a delta record of sectional flooding and T reworking, revealing a dynamic environment where the interplay of varying input and T moderation is key. Finally, we examine the volcanic island at setting of St. Vincent, and this island is formed by the subduction of the Atlantic plate. And in this region is one part of the Andes, where active volcanism drives a unique sedimentary systems. In this island, we contain three major surface processes. So the first of all is volcanic eruption and ashfall. So it's about heavy tropic rains trigger hala that transport angular volcanic crust downslope to form breccias. And in low energy coastal freewheel setting, its steep slope combined with high rainfall lead to frequent landslides and fluvial erosion. So in this process will produce deposits that may eventually lithophile into conglomerate or volcaniclastic sandstones. And for coastal reworking, the coastal zone subject to vigorous wave acted the long shell current. Reworking volcanic sediments deliver from islands. Those processes can result in well-sorted, close-bedded volcaniclastic sandstone along the shell line. Like we talking about log types, so for example 581 is a visible grain texture such as sand-sized particle, and it appears moderately sorted individual grain can be seen by us. And I can see some clear grains such as coal and dark fragments such as volcanic lithite, and its moderate textural maturity because grains show partial rounding and moderate sorting, and for its compositional maturity is moderate because the processing of feldspar and volcanic lithite only had a few of compositional maturity. For sample 534 is indicate a high proportion of volcanic gas because it's too much dark matrix, and for its grain it appears to be the fine to medium sand range, and its moderate setting because majority of grain look fairly uniform, and the most grain are subangular to subrounded. After that is some reference citations. In conclusion, each environment illustrates a distinct interplay of surface process. In the Mojave Desert, the combination of wind drive transport the episodic water flow led to formation of polysorted, cross-bedded conglomerates and cause arenites. In Bangladesh, the massive raining import coupled with Thai and musonal influence and enhanced by mangrove stabilization, resulting in the deposition in fine-grained millstone and siltstone with organic rich layers. On volcanic island, active volcanism produces a suite of volcaniclastic rock from tuff to and laharic breccia to volcaniclastic sandstone and dacitic lithurites, each reflecting different depositional setting controlled by eruptive events and coastal reworking. So those case study not only underscored how surface process vary dramatically with climate and tectonic, but also illustrate common themes, sorting, reworking, and the transformation of loose sediments into logs. So thank you for your attention, and I will look forward of any question you may have.